Exercise number 5.1. Question number 1. A missile fired from ground level rises x meters vertically upward. Rises x meters vertically upwards in t seconds, and x is equal to 100t minus 25 by 2t square is our given function. A function in which t is the dependent is the independent variable and x is the dependent variable. So we have find first one, the initial velocity of missile. Initial velocity of missile. The second one is the time when the height of the missile is a maximum. The time when the height of missile is maximum. And the third one is the maximum height reached. The maximum height reached. And the fourth one is the velocity with which the missile strikes the ground. The velocity with which the missile strikes the ground. Okay, first we have write our given data. So our data is, as you see, we have given the equation, or I say the function, in which the time is the independent variable and x is the dependent variable. So first we have given the function which is x is equal to 100t minus 25 by 2t square. And it is also mentioned in the question that x in meter and t in second. So x in meters and t in second. So we name this function or this relation as star. Okay, so what we have find in the first part, we have find the initial velocity of the missile. So as it says that find the initial velocity, then our strategy must be we take the derivative of this relation, as we know that dx by dt is the velocity. So we first take the derivative of this equation and then put the time is equal to 0 in our derivative equation. So from this we can find the the velocity, the initial velocity. So first take the derivative. Take the derivative with respect to t, with respect to time. Dx by dt is equal to, take the constant out, and when you take the derivative of t, then it will be dt by dt. So dt by dt cancel with each other, so we get the 100, means dt by dt, it is cancel, we get only the 100, a constant number. Now minus 25 by 2, take this thing out and take the derivative of t square. So the derivative of t, first remember this formula, which is x ki power n, derivative with respect to x ki power n is equal to n into x ki power n minus 1. Remember this general relation, and now take the derivative of this term t square. Take the n should be the 2, so 2 times x ki power 1. Okay, the 2 cancel with 2, dt by dt cancel, and we get a derivative, dx by dt is equal to 100 minus 25x. Sorry, this should be the t, not x. This should be the t, because you see that here we have t, not x. Okay, so 25t. Now we get the final relation is dx by dt is equal to 100 minus 25t. Okay, so as we find the initial velocity, so we must put t is equal to 0 in that equation. Name this equation as 1. When we put t is equal to 0, when we put t is equal to 0 in this equation, we get the answer, as we know that dx by dt is equal to v is equal to dx by dt is equal to 100. When we put t is equal to 0 in 1, when we put t is equal to 0 in 1, then put it 0 here, this term will equal to 0, and we only get the 100. So as we already or as this is already given in the question that x in meter and t in second, so the unit of the velocity must be meter per second. So now we are done with our first part. Now our second part is the time when the height of the missile is maximum. Now we find the time when the height of the missile is maximum. So for this part, our strategy is when the height is maximum, then the velocity is equal to 0. So we put 0 in equation 1 in place of velocity, because when the height is maximum, when the height of the ball, or the here it mentioned the missile, when the height of the missile is maximum, then the velocity, this velocity term is equal to 0. Okay, so put dx by dt is equal to 0, means put equation 1, this is equation 1, put it is equal to 0 and find the time from this equation. This is our second part. So now put from our equation 1 is dx by dt is equal to 100 minus 25t. This is our equation 1. We name it as equation 1. So in order, this is part 2. So in order to find the time when the height of the missile is maximum, put dx by dt is equal to 0. When you put dx by dt is equal to 0, you get the equation 100 minus 25t. Now take this term to the opposite side, or in mathematics we say that minus 100 on both sides. So our equation become 25t is equal to 100 divided by 25 on both sides, we get t is equal to 4 seconds. This is our answer. Now in third part is it says that we have to find the maximum height reached. So in order to find the maximum height reached, as we already find the time for the maximum height, so we put this time in the distance or distance equation or the function which is our part 3. We have this relation, we are given with this relation, x is equal to 100t minus 25 by 2t square. Now as we find the time in this part 2, as we find the time for the maximum height reached by the missile, so we put this time t is equal to 4 in this relation and find the x. So x is equal to 100 into 4 minus 25 by 2 into 4 whole square. So as we calculate, 100 into 4 is equal to 400 minus 25 by 2 into 16. So this must be 200 meter. 400 minus 25 by 2 into 16, calculated, it must be equal to 200 meter. So in the part 4, we have calculate the velocity with which the missile strikes the ground. So when the missile strikes the ground, then we assume that the distance is equal to 0. When it strikes, we take the ground as our reference. So we say that the distance is equal to, or the displacement is equal to 0. So in our displacement equation, which is x part 4 is equal to x is equal to 100 t minus 25 by 2 t square. So in order to find the velocity with which the missile strikes the ground, first we find the time from this equation and then put in the velocity equation, which is dx by dt, as we find earlier. So put x, our displacement, is equal to 0, because from which the missile starts, it end up at the same point, so the displacement is equal to 0. So put x is equal to 0 here. So x is equal to 0 into 100 t minus 25 by 2 t square. Take the t term common. 100 minus 25 by 2t. Now we have two answers for the t. One is t is equal to 0 and the other is t is equal to, which is come from this equation, t is equal to 8. T is equal to 0 second or t is equal to 8 second. The displacement is equal to 0 because the missile starts from the point and it comes after cover a long distance at the same point. But the time never equal to 0 because as he covers some distance, then or he covers some path, so he must use some time. So he also must require some time to cover that path. So we ignore this because it is impossible. So we take t is equal to 8 seconds as our answer. So put in the equation. put in this equation. V is equal to dx by dt, dx by dt is equal to 100 minus 25t. Put in equation 1, because in this part we have find the velocity with which the missile strike the ground. So in order to find the velocity, put the time here and find dx by dt, which is the velocity. So from equation 1, from equation 1, put time here, dx by dt is equal to 100 minus 25 into 8 is equal to minus 100 meter per second. So it shows that it shows the negative sign, which means that the direction, it means that in opposite direction. Okay, so because it is in downward direction, as we take our axis upward positive and downward negative, as the velocity is in downward direction, final velocity is in downward direction, so it must be with a negative sign. Okay, now we are moving toward our part 2. In question number 2, it says that a particle of unit mass moves so that displacement after t second is given by. A particle of unit mass moves so that displacement after t seconds is given by this relation, x is equal to 3 into cos 2t minus 4. So what we have find? We have find first part, find acceleration at t is equal to 2 seconds, and in part 2 find the kinetic energy at t is equal to 2 seconds. So first we write our given data. So our given data is only given data is our relation, which is x is equal to 3 cos into 2t minus 4. Here t is independent variable and x is dependent variable. So x is equal to 3 cos 2t minus 4, and we have to find the acceleration at t is equal to 2 seconds, and then the kinetic energy at t is equal to 2 seconds. In order to find the acceleration, we first have take the double derivative of this displacement, because the single derivative of displacement is equal to velocity, and then if we take the derivative again, then it is equal to acceleration. So dx by dt is equal to 3 derivative of cos. Derivative of cos is equal to minus sign, and we also take the derivative of this part, because you always remember this derivative form, d over dx of cos x is equal to minus sine x, and also derivative of this x, which is equal to 1. So that's why we write derivative of cos x is equal to minus sin x. But we also take the derivative of this term, this x term. So 3 into derivative of cos is equal to minus sine into 2t minus 4, and also take the derivative of 2t minus 4, which is equal to 2, because derivative of constant number is equal to 0, and derivative of t with respect to t is equal to 1. So multiply by 2. Okay, take this 2 outside, it becomes 3 2s are 6, minus, take this minus also outside. So dx by dt is equal to minus 6 into sine of 2t minus 4. Okay, now take this is equal to velocity. Now take a derivative again, d over d with respect to t into dx by dt is equal to, this gives us the acceleration, because this whole term is equal to acceleration. So minus 6 into derivative of sine is equal to cos, and the same procedure as we done here, but here the derivative of sine is equal to cos, here the derivative of cos is equal to minus sin x. So derivative of sine is equal to cos into 2t minus 4, and also take the derivative of 2t minus 4, which is equal to 2. So 6 into 2 is equal to 12, okay, into cos of 2t minus 4. Now in order to find the acceleration, at 2 seconds, put the time here is equal to 2. So minus 12 into cos into 2 into 2, because we have because in our first part we have to find the acceleration at t is equal to 2 seconds, minus 4, okay, minus 12 into cos of 4 minus 4. So 4 minus 4 is equal to 0. So cos of 0 is equal to 1. Cos of 0 is equal to 1. So the answer will be minus 12. In order to find the kinetic energy, we must put t is equal to 2 seconds in the velocity equation. As we find the velocity equation in that problem, which is the dx by dt is equal to minus 6 into sine into 2t minus 4. Put t is equal to 2 here and find the velocity, and because we in our second part it says that we have to find the kinetic energy at t is equal to 2 seconds. So in order to find the kinetic energy, which is equal to kinetic energy is equal, this is our part 2, the kinetic energy is equal to half mv square. So we need the velocity. So as we find the velocity from this relation, dx by dt is equal to minus 6 into sine into 2t minus 4. Okay, so put t is equal to 2 seconds, put t is equal to 2 here, and find the dx by dt which is equal to the velocity. So minus 6 into sine of 2 into 2 into minus 4. Okay, so 2 into 2 minus 4, it is equal to 0, because 2 2s are 4, 4 minus 4 is equal to 0, and sine of 0 is equal to 0. So dx by dt is equal to 0. Means the kinetic energy is equal to 1 by 2 mv square. So here the velocity term is equal to 0, so kinetic energy is equal to 0. Okay, now in the third question, the distance x meters traveled by a vehicle, the distance x meters covered, the distance x meters traveled, traveled by a vehicle in time t second after the brakes are applied is given by, after the brakes are applied is given by x is equal to 20t minus 5 by 3t square. Determine what we determined. Firstly, the speed of the vehicle in kilometer per hour at the instant the brakes are applied. The speed of vehicle in kilometer per hour at the instant the brakes are applied, at the instant the brakes are applied. Okay, and the second part is the distance the car traveled before it stops. The distance the car traveled before it stops. So for this, first we write our given data. So our given data is the relation of x with time is x is equal to 20t minus 5 by 3t square, and it also mentioned in the question that x in meters. It also mentioned in the question that x is meter and the time t in second. But what it demands the kilometer per hour, mean the speed in kilometer per hour. So we our x, it mentioned in the question that x in meters and time in second. So but what he demands that we have in our first part we have find the speed of the vehicle in kilometer per hour at the instant the brakes are applied. So we take as these equations is given after when the brakes are applied and when it stops actually means it covers some displacement. So it is the equation of that displacement in which the vehicle covers some distance, or vehicle covers some displacement after the brakes are applied. So we take our interval from that instant at which the brakes are applied and up till that displacement when the cars actually stop. So our time when the brakes are applied, then the time t is equal to 0, because this displacement equation is given for that interval when the brakes are applied and up till when the car actually stops. Okay, so our time starts from that moment when the brakes are applied. So in order to find the speed of the vehicle at the instant the brakes are applied, we must take the derivative of this equation and then put t is equal to 0 in this equation. So now take the derivative dx by, with respect to t, dx by dt is equal to 20. Take the 20 out, and then the derivative dt by dt is equal to 1. So 20 left, minus 5 by 3. Derivative of t square is the same as the derivative of x to the power n. So take the derivative of t square, it must be 2t, and then the dt by dt is equal to 1. Okay, so now put name this equation. First we simplify it, which is equal to 20 minus 10 by 3t. Name this equation as 1. Okay, now put t is equal to 0 in this equation 1. Okay, put t, this is our part 1. We solve this for part 1. Put t is equal to 0 in equation 1. And which is our equation 1? Equation 1 is dx by dt is equal to 20 minus 10 by 3t. Put t is equal to 0. When we put t is equal to 0, then we get 20 meter per second. But we convert this meter per second in the kilometer per hour. So as he mentioned in the question that we require the answer in kilometer per hour. So in order to convert the 20 meter per second in kilometer hour, we do some calculation which is as follow. We multiply with as 1 kilometer is equal to 1000 meter and 3600 seconds is equal to 1 hour. So do some calculation here. The second cut with second and the meter cut with meter, so the answer remain in kilometer per hour. This 20 cut with this 20, so by multiplying with this 0 cut with this 0, when we multiply it with 36 multiplied by 2 is equal to 72 kilometer per hour. Okay, so 72 kilometer per hour. This is our first answer. Okay, now in order to find the second part, in which he demands that we have to find the distance the car traveled from before it stops. The distance the car traveled before it stops. In order to find the distance the car traveled before it stops, first we find the distance the car traveled before it stops. So when the car stops, then the velocity is equal to 0. Okay, so in order to find the distance the car traveled before it stopped, we must put this equation is equal to 0 and find the time from this equation and then put it in the original displacement equation. Okay, so put the dx by dt is equal to 0. Okay, 0, this is our part 2. 0 is equal to 20 minus 10 by 3t. 10t by 3 is equal to 20. Okay, and then multiply by 3 here, so 10t is equal to 3 into 3 to 6, 60, and then t is equal to 6 seconds. Now put this t in the original equation, in our original displacement equation, in order to find the distance or the distance the car traveled before it stops. So put this t is equal to 6 seconds in this equation. X is equal to 20t minus 5 by 3t square. Let's name it as star. Okay, so put the t is equal to 6 seconds in this equation. Okay, so x is equal to, this gives us the distance or the distance the car traveled before it stops. So x is equal to 20 into 6 minus 5 by 3 into 6 whole 5 by 3 into 6 whole square. Now is equal to 60. This is 60 meter because it is given in the question that the displacement or the distance is in 6 meters. Okay, now we are done with 3 questions, and now let us move toward our fourth question. Our fourth question is about the Newton law of cooling, and from this we find the rate of change of temperature. Now first write the question. Our fourth question is, the Newton laws of cooling is given by Newton laws of cooling is given by this relation theta is equal to theta naught, which is in degree, e raised to power minus kt. Okay, where the excess of temperature at 0 time, where the excess of temperature, this is short form of temperature, at 0 time is theta naught in degree Celsius, and at time t second is theta naught degree C, and at time t second is theta degree C. Determine the rate of change of temperature. Determine the rate of change of temperature. Determine the rate of change of temperature after 40 seconds. After 40 seconds. Given what is given? Given that what is given? Theta naught is equal to 16 degrees Celsius. Okay, and K is equal to minus 0.03. K is equal to minus 0.03. So first I explain the problem, which is this we are given with this relation. Theta is equal to theta naught degree e raised to power minus kt. Here the theta is at time t second, and that the temperature we measure at time 0 is theta naught. The theta is that temperature which we measure after t second, and the theta naught is that temperature which we measure at time t is equal to 0. So here this k, the constant appears, and we also given its value, which is k is equal to minus 0.03, and we also given theta naught, which is the constant value at time t is equal to 0, is equal to 16 degrees Celsius. Okay, now in order to find the time at t is equal to 40 seconds, now in order to find the rate of change of temperature after 40 seconds, first we take the derivative of this relation with respect to t. Okay, so first we take the derivative. First we take the derivative of the relation. The relation we given is theta is equal to theta naught into e raised to power minus kt. Okay, first we take the derivative of this with respect to time, because we find it is mentioned in the question that we have to find the rate of change of temperature. The rate is the time, the rate of change of temperature. So we take the derivative of this temperature theta with respect to time. D theta by dt is equal to, as theta naught is constant, we take it out. So theta naught is constant. Now take the derivative of e raised to power minus kt with respect to time. Okay, so the theta naught derivative of e raised to power minus kt is e raised to power kt minus e raised to power minus kt as it is, and derivative of minus kt as a derivative of minus kt. As k is constant, we take this constant out and take the derivative of dt by dt. As dt by dt is equal to 1, so the end result is e raised to power minus kt into minus k. Okay, as we have given the value of theta naught, and also k, theta naught is equal to 16 and k is equal to minus 0.03. so put these values in this equation. 16, this is in degrees Celsius, so the whole term, as k is constant and time is in second, so 16 into 16 into e raised to power minus here k is equal to minus 0.03. so put the value here, minus 0.03. And at what time we calculate it? We calculate it at t is equal to 40 second. So t is equal to 40 second. Put the time t is equal here. T is equal to 40 second here, and then put the value of minus into minus 0.03 here. The answer we get is 1.5936. When we round this answer, when we round off this answer, it is equal to 1.6 degrees Celsius and degrees Celsius, 1.6 degrees Celsius. As we find in this question the rate of change of temperature after 40 seconds. So the answer must be in degrees Celsius per second. So 1.6 degrees Celsius means 1.6. This means that 1.6 degrees Celsius temperature at t is equal to 40 seconds. Okay. Now this is our question number 4. This is the question number 4, and now we have moved toward the question number 5. In question number 5, it says that the altitude of triangle is increasing. The altitude of triangle is increasing at a rate of 1 centimeter per minute, and while the area of the triangle is increasing at a rate of 2 centimeter square per minute. At what rate is the what we have calculated? He demands us that we calculate at what rate is the base of triangle changing. At what rate the base of triangle is changing when the altitude is is 10 centimeter and the area is 100 centimeter square. First we write the given data. So the given data is dH by dt, means the rate of change of altitude. We represent h by altitude, and a by area. So rate of change of altitude, dH by dt is equal to 1 centimeter per minute, and dA by dt is equal to 2 centimeter square per minute. And as we given that h is equal to 10 centimeter and area is equal to 100 centimeter square. Okay, so now we have what we find we have find at what rate is the base of the triangle changing. We have find what we have find at what rate the base of triangle changing. Okay, so as we know the area of the triangle. So what is the area of the triangle? The area of the triangle is A is equal to 1 by 2 BH. Here we represent B by base. B represents the base. Okay, so as we find the rate of change of the base, so we take the derivative on both sides. Take the derivative on both sides. dA by dt is equal to d by dt with respect to t. We take the derivative with respect to t because he demands in the question that we have to find the base. The rate of change of base means the base changing with respect to time, so we take the derivative with respect to time. As 1 by 2 is constant, take it out into BH. As B and H both are variable, so we apply the product rule of derivative. So what is the product rule of derivative? First, the product rule of derivative is d by dt of f of x and g of x. As f of x and g of x are two functions, so f of x and g is equal to f of x as it is and derivative of g of x, and then g of x as it is and derivative of f of x. This dash sign represents the derivative. Okay, so take the derivative of b and h on the same method as we take the derivative of f of x and g of x. So 1 by 2 into derivative of first take b as it is and derivative of h dh by dt plus now h as it is and take the derivative of b is equal to db by dt. Okay, now as in this part we know about dh by dt. We also know about dA by dt. We also given h, and we have find this thing, but in this whole relation we do not know about b. So in order to find the value of b, we again use this equation. This relation of area A is equal to 1 by 2 BH. We use this formula and find the B because we are given with A and H. Okay, so name it as 1. As we are given with A and H, as we know that the H is equal to 10 centimeter and area is equal to 100 centimeter square, and we are also given with dH by dt and dA by dt. So what we found from these two values, we found the value of B, the base. Okay, so in order to find the base, put A is equal to 1 by 2. We use this relation and this formula. BH here area is equal to 100 centimeters square, and 1 by 2 we have to find the b, and h is equal to 10 centimeter. So when we divide by this 10 and multiply by 2, we get b is equal to 20 centimeter. Put this b value in this derivative equation, as we have the value of dA by dt, which is equal to 2, is equal to 1 by 2 into now we have find the value of b, which is equal to 20 centimeter. Put it here 20, and we also have the value of dH by dt, which is equal to 1, and we also have the value of h, which is equal to 10. So now we find from now we find the value of dB by dt. So in order to find the value of dB by t, multiply by 1 over 2 inside this inside this this relation, or this expression, multiply by 1 by 2 in this expression, inside this expression, or multiply it the other side, means multiply by 2 on both sides. So this is easy, multiply by 2 on both sides, this is easy for us. So when we multiply by 2 on both sides, here we get 4 is equal to 20 plus 10 dB by dt. Take the 20 on the opposite side. Take the 20 on the opposite side. 4 minus 20 is equal to 10 dB by, or minus 20 on both sides, dB by dt. So here we get minus 16 is equal to 10 dB by dt, multiply divided by 10 on both sides. So we get minus 16 divided by 10 is equal to, minus 16 divided by 10 is equal to dB by dt. So from this answer, we know that we conclude that the base is not increasing, but it is decreasing. It is decreasing by minus 16 over 10. So it's dB by dt is equal to minus 16 over 10 centimeter per minute. So dB by dt, the base is decreasing minus 16 centimeter per minute, minus 16 by 10 centimeter per minute. The base is decreasing by minus 16 by 10 centimeter per minute. Okay, so this is the answer. Now in the question number 6, first we write the statement of question number 6. So question number 6: at noon, ship A is 100 km west of ship B. Ship A is sailing east at ship A is sailing east at 35 km per hour, and ship B is sailing north at 25 km per hour. Okay, how fast is the distance between the ship changing at 4 p.m.? How fast the distance means how fast means we have find the velocity, how fast, or the speed. Basically we have find the speed, how fast the distance, because he mentioned the distance. How fast the distance means we have to find the speed. How fast the distance between the ships changing ships changing at 4 p.m. Okay, so first we make the diagram and then we write our given data. In this question we take another approach in which we first make the diagram and then we write our data. So in the diagram it is in the diagram we have make the axis in which we show the north, south, east and west. So first we make the axis. This is our axis. Okay, so here is the north, here is the south, and here is the east, and here is the west. Okay, so mark this point as P, mark this point as Q, mark this point as P dash, and mark this point as Q dash. So at as it is mentioned in the problem that at noon ship A is 100 km. At noon we take the noon time t is equal to 0 because it is the starting point. At noon the ship A is 100 km west of ship B. So ship A is 100 km west of ship B. Ship A is 100 km. This is the initial position of ship A. The Q point is the initial position of ship A, and it is 100 km west of ship B. And it is also mentioned in the problem that ship A is sailing east, so that means from west it is sailing towards east at 35 km per hour, means it is sailing at 35 km per hour toward east. So if we take the point P our region and we say that the ship A is at 100 km when it is at point Q, so when it is at point Q dash then it is 35 T, because it is mentioned in the problem that the ship A is sailing at 35 km per hour. So 35 T minus 100 km is our point Q dash. Okay, and as it is mentioned in the problem that the ship B is sailing north at 25, means ship B is sailing north at ship B is sailing north at 25 T. So here we mentioned that our point P dash, so when ship B is sailing toward it, so at 4 ship B is sailing toward the north, and we mentioned this by point P dash. So here it is 25 T, and we measure the distance. How fast is the distance between the ship changing at 4 p.m. So distance between ships. So this is the position P dash and this is Q dash, and we measure that distance. We made this hypothetical picture so that we imagine what is going on. So we measured this distance. So as you see that we measure this distance. So and this is the right triangle. We also use the Pythagoras theorem in order to find this distance. But what we have find the how fast is the distance between the, means what is the speed between these two ships. So we must take the derivative of the distance, but first we find the distance from the Pythagoras theorem. Now write the given data from this figure you can easily write the given data, or you do the same, you use the same approach by first writing the given data and then write the and then make this diagram. And I see that first we must write the given data first, because I also suffer some problem in making this diagram. So at noon, ship A is 100 kilometer west of ship B. So ship A is 100 kilometer west of ship B. This is our first point. May write it in first point, and we also know that ship A is sailing at 35 kilometer per hour. Ship A is sailing at 35 kilometer per hour toward east. Okay, and our third point is ship B is sailing north at 25. Ship B is sailing towards north at 25 kilometer per hour. Okay, and what we have to refer we have find but we find we will find the distance between the ships changing at 4. Distance how fast distance how fast the distance is changing. Between how fast the distance is changing between the ships at 4. How fast the distance is changing between ships at 4 p.m. Okay, so in order to find this problem, as we mentioned P dash and Q dash, so we also write in our given data here, so we can perform easily our problem and approach toward answer easily. So P Q dash distance is equal to P Q dash distance is equal to 35 t minus 100, and P dash distance is equal to 25 t, and P dash Q dash distance is equal to, means this distance, P dash Q dash distance, this is equal to S, and we mention it as S, and after it we take the derivative of this S and find how fast the distance is changing. Okay, so first we take the first we apply the Pythagoras theorem, because it is the right triangle. Here the angle is 90. We can apply the Pythagoras theorem to the right triangle. So S square is equal to 35 minus t 35 t minus 100 whole square is plus 25 t whole square. Okay, so now take the derivative, because we have find how fast the distance is changing. So now take the derivative d. When we take the derivative, d s square by dt, take the derivative on both sides with respect to t, d over dt into 35t minus 100 whole square plus g by dt into 25t whole square. Now ds square by dt is equal to 2s ds by dt, and 35t minus 100 whole square is equal to d is equal to 2 into 35t minus 100, and now take the derivative of inner term, which is equal to 35. Now multiply by 35 plus derivative of this term 2 into 25t, and now the derivative of 25t is equal to 25. Okay, so now this is the whole term 25 2s into ds by dt into 2 into 35t minus 100 into 35 plus 2 into 25t into 25. Okay, so now as we have seen that at noon the time t is equal to 0, and we have find the speed at 4 p.m. So at noon when the time t is equal to 0, and we have find the speed at time t is equal to 4. So we have the value of t, but we do not have 1 by 2s. We do not have the value of this s, the distance between the two ships, the distance between this p dash and q dash. We do not have the value of this distance s, which we call the s. P dash q dash, we call it as s. We do not have this value. So in order to find this value, we must for example, first we simplify it. This is 2 multiplied by 35 is equal to 70 into 35t minus 100 plus 2 multiplied by 25 is equal to 50, and 50 multiplied by 25 is equal to 1250t. Okay, now in order to find the value of s, we again write the distance formula and put t is equal to 4 in it. For example, we found this value from this equation: s square is equal to 35t minus 100 whole square minus 25t into whole square. We name it as 1 and put t is equal to 4 in this equation. Okay, so s is equal to whole under root 35t minus 100 whole square plus 25t into whole square. Now put t is equal to 4 seconds, because it is mentioned in the problem that at noon the ships are sailing at that positions, and we have find the speed at between the two ships at 4 p.m. So we take the noon time t is equal to 0, and we take the 4 p.m. is equal to 4. Now put t is equal to 4 seconds in this equation. When we put t is equal to 4 seconds in this equation, we get under root 35 into 4 minus 100 whole square plus 25 into 4 whole square. And when we simplify it, we get 20 into under root 29. Now put this s value here and put t is equal to 4 in order to find the ds by dt. Okay, so now in order to find the ds by in order to find the ds by dt, which is equal to 1 over 2s into 1 over 2s into 70 into 35t minus 100 into plus 1250 t. Okay, so put t is equal to 4 seconds and s is equal to 20 into under root 29, which we found from our previous Pythagoras theorem relation. Okay, when we put these two values here, we get 1 over multiply by 1 over multiply by 1 over 2 inside the equation, and we get 1 over s into 70. When we multiply by 1 over 2, when we multiply this 1 over 2 inside, this will become 35. My mistake. 35 into 35t minus 100 and plus when we multiply by 1250 by 1 over 2, we get 625t. Okay, now put t is equal to 4 and s is equal to 20 into under root 29 here, and put s is equal to 20 into under root 29 and 35 into 35 into 4 minus 100 plus 625 into 4. Here we get 1 over 20 into under root 29 into 3900. When we simplify this whole expression, we get 3900. Okay, and when we divide it by 20, we get 195 over under root 29 kilometer per hour. This is the answer. Means the speed ds by dt between p dash and q dash, which we have between p dash and q dash between two ships at their final position is 195 by under root 29 kilometer per hour. Okay, now moving to the question number 7. Two sides of a triangle are 4 meter and 5 meter. 4 meter and 5 meter in length, and the angle between them is increasing, and the angle between them is increasing at a rate of 0.06 radian per second. Find the rate at which the area of the triangle is increasing when the angle between the sides of the fixed length pi by 3. So in order to solve this question, we first write the given data. We are given what we given is two sides. What we given is two sides of the triangle are 4 meter and 5 meter, and these sides are fixed. So two sides. For this we make the diagram. Consider this triangle. Okay, and he says that two sides of the triangle are 4 meter and 5 meter. So assume that the two fixed sides are these two sides. 5 meter and 4 meter, and this side is a variable side, and we name it as x meter, means it is changing 5 meter and 4 meter. And he also given that the angle between them is increasing at the rate of 0.06 radian per second. So the angle d theta by dt is equal to 0.06 radian per second. Okay, and he also given the angle between the sides of fixed. When these two sides as these two sides are fixed, he is given the angle between them, which is equal to pi by 3. This angle is equal to pi by 3. Okay, at this moment we do not know about that either this side is a right triangle or a right triangle or obtuse or acute. We do not know what is this. We do not know about this triangle. Okay, so as we know that the area of the triangle area is equal to 1 by 2 BH. We know about the area. But we find we have to find the area of the triangle, at what rate the area of at which rate the area of the triangle is increasing. So we must take the derivative, but before moving onward, we bisect this side by we bisect or draw a line which passes from this point and cut this side. So when we draw this line, then the right side of this line, the right side of this line is the right triangle. You see that this is the right triangle. We do not need this, and this variable side is irrelevant for us. So from this you can find the relation. You do not know about at what point this line cut this triangle, but you have the relation of sine theta. And why we need this relation, I'll tell you. Because we are given with d theta by dt, means the rate of change of angle with respect to time. But in our area equation we do not have angle. So in order to put the angle here, because we are given with d theta by dt, we are not given with dh by dt. So we must convert this h. We must convert this h in d. We must convert this h in d theta by dt. So sine of theta is equal to h by 5. Sine theta is equal to h by 5, and here we get h is equal to 5 sine theta. Okay, so now as from this we make the we now put the area is equal to 1 by 2, as we given the base, which is equal to 4, and the height relation we find from this is 5 of sine of theta. So by simplifying this, 5 into 4 is equal to 20, and divided by 2 is equal to 10 of sine theta. Now you can see that we are left with the relation of area with only theta, and we also given the d theta by dt. So that's why we convert h into sine theta. So we put the values, and the whole relation is in now theta. Now take the derivative now. dA by d with respect to d. 10 derivative of sine is equal to cos theta, and derivative of theta is d theta by dt. Okay, now we now the fixed angle theta. We know the d theta by dt by putting the values. Tan into cos of the theta angle, theta is equal to pi by 3, and d theta by dt is equal to 0.06. okay, now tan into cos pi by 3 into 0.06, cos of pi by 3 is equal to 1 by 2, means cos of 60 is equal to 1 by 2 multiplied by 0.06, so we get the answer 0.3 unit square per second. Our question number 9 is gravel, G-R-A-V-E-L, gravel is being dumped from a conveyor belt, from a conveyor belt at a rate of 30 feet cube per minute. Okay, and it is person and it is person such that it forms a pile in the shape of a cone whose base diameter and height are always equal. Point to be noted, whose base and diameter are always equal. How fast is the height of the pile? How fast is the height of the pile? Increasing when the pile is 10 feet high. Is increasing when the pile is 10 feet high. This is our question number 9, and this is the last question of exercise 5.1. What demands and what is given in the question? We write first. Gravel is being dumped from a conveyor belt at a rate of 30 feet cube per minute. The volume is given. And basically we say that the rate of change, the rate of volume is given. 30 feet cube per minute. The rate of volume is given, means dV given. This is our given data. Given data is dV by dt is equal to 30 feet cube per minute. Okay, as it is mentioned in the question, the pile is formed in such a way that it formed the cone. So this is the volume of the cone is changing per unit time, is equal to 30 feet cube per minute. We also given that the height of the pile, the height h of the pile is equal to 10 feet, and we also given that the diameter, the base diameter and the height are always equal. The base diameter and height are always equal. This is very important point. So as we know that the volume of the what we find, we how fast is the height of the pile increasing, means we have find the d we have find the height, at what rate the height is increasing. So for this moves onward, as the volume of the cone is equal to v is equal to 1 by 3 pi r square into pi r square into h, and as it is mentioned in the, and as it is this is the radius, and it is as it is mentioned that in the question that the base diameter and the height are always equal, we can say that the diameter d, which is equal to h, is equal to x. Now the radius r is equal to x by 2. Okay, these are very important points. Put it here. Volume V is equal to 1 by 3 pi, replace r by x by 2 whole square and replace h by x. Okay, now V is equal to 1, the square of 2 is equal to 4, and multiply by 4 by 3 is equal to 12, 4 pi x cube. Now take the derivative with respect to time. Name it as equation 1. Now take the derivative of this equation. Our equation is V is equal to 1 by 12 pi x cube. Take the derivative, dv by dt is equal to 1 by 12 is constant, pi is constant, take them out and take the derivative of x cube. The derivative of x cube is 3x square into dx by dt. Now as we have to find dx by dt, how fast is the height of the pile increasing, so we have find this dx by dt, and we also given the value of dv by dt, and we also have the value of height h. So put the values here. We get the answer 30 into 1 by 12 pi into 3 into the height h is equal to as we are given in our question, height h is equal to 10 feet. 10 square into dx by dt. Okay, take them to the other side. 30 into 12 divided by pi into 310 square. When you solve or simplify this, it is equal to 6 by 5 pi. It is equal to 6 over 5 pi feet, 6 over 5 pi feet per minute, means the height of the pile is increasing at the rate 6 over 5 pi is equal to dx by dt. You can also replace x by h. It is all about the exercise 5.1, and we solve 9 sums in this exercise, and thank you so much.